Hello, and welcome to another micro tutoring session from Prep Plus. Prep Plus micro tutoring sessions unlock the secrets of common math and physics, homework, and exam problems. Today's problem is in linear algebra, which is an undergraduate college topic, and it involves the solution for the matrix square root, the square root of a matrix. Now, there are at least two different ways to do this problem. And today we will use a method involving eigenvalues and eigenvectors, and we obtain those necessary eigenvalues and eigenvectors in another micro tutoring session. So today we'll just use the result from another micro tutoring session. So let's just get right down to it. Let's say on your linear algebra exam, you're given a matrix A, 5, -3, -3, and 5. And the question is to find another matrix M such that the square of M equals the matrix A. So we're given A, find M such that M squared equals A. And today we're going to use a method involving eigenvalues and eigenvectors to get the answer. So let's get down to it. So now first of all, we look at this matrix A and we say, well, all the elements are real, so that's important to notice. And we also notice that it is symmetric. So these two elements are the same, so they're the same across the diagonal of the matrix. So this is a real symmetric matrix. So it probably also has real eigenvalues. So if all of these things are true, then the solution is M equals V, the square root of the D matrix, times V inverse. So now what is this? So if we diagonalize our initial matrix A, which means to find its eigenvalues and eigenvectors, then it can be written as V, D, V inverse, where V is a matrix whose columns are the eigenvectors of A. D is a diagonal matrix with the corresponding eigenvalues, and then V is just the inverse, or V inverse is just the inverse of the V matrix with the whose columns are the eigenvectors. So if we first solve the eigenvalue problem of A, and we get the matrix V and the matrix D, then we can use that result to get the solution for the square root of A, where the square root is M equals matrix V times the square root of the diagonal matrix whose elements are the eigenvalues, D, times the inverse of the V matrix. Okay, so let's go ahead and do this. So what we obtained in another micro tutoring session is what the eigenvalues and eigenvectors are. So we can immediately write down what the V matrix is and the D matrix. So V that we obtained earlier is, let me write it over here. So the V matrix that we obtained in another micro tutoring session equals 1 over the square root of 2. One eigenvector is this, and the other one is this. And then D, the D matrix, and recall that I use the notation double underscore to denote a matrix, and a single underscore to denote a vector. So this D matrix, the diagonal matrix whose elements are the eigenvalues, is 2, 0, 0, 8. So again, the matrix V and matrix D we obtained in another micro-tutoring session for the solution of eigenvalues and eigenvectors. And so we have these two vectors. So now the only thing left for us to do to get the solution for the square root matrix is to invert the V matrix. Okay, so let's get down to that. Recall that the inverse of a matrix, this formula is 1 over the determinant of the matrix times the transpose of the matrix of cofactors. Okay, so so that's a mouthful, but it's very straightforward to calculate. V inverse equals 1 over the determinant of V matrix V times the transpose of the matrix of cofactors. All right, so let's go ahead and calculate the cofactor matrix and then transpose it. All right, so then the cofactor matrix of V equals, all right, this is V minus 1 to the 1 plus 1 of 1. This is minus 1 to the 1 plus 2 row plus column 1, and minus 1 to the row 2 plus 1 minus 1, and then minus 1 to the row 2 plus column 2 times 1. Okay, that's just the cofactor matrix, and this is 1, this is minus 1, this is minus 1 times 1, minus 1, and this is 1. And then we want the transpose of this, which is 1. We're going to put that down there. The minus 1 goes down there. Then this 1 goes up here, and the diagonals are the same. Okay? So the this is we have a 1 over square root of 2 out here. 1 over square. Sorry about this. It's always important to keep all the terms of your equation. Keep them all there. Okay. So now, this is the inverse of the, this is the transpose of the matrix of cofactors, and now we need to calculate the determinant of the V matrix. It is, it's actually, if we just look at it, the determinant of this V matrix is 1. All right, so then what we need is M equals the V matrix times the square root of the D matrix times V inverse. All right, so we're filling up the space here. Now we're going to go all the way up here. So then V is 1 over so V is this, 1 over the square root 2 of the matrix. 1, 1, minus 1, 1. Okay? And the square root of the D matrix is square root of 2, 0, 0, square root of 8. And then the inverse of the V matrix is this guy. One over the square root of 2. One minus 1, 1, and 1. So now, so this is the formula for the square root of this matrix using eigenvalues and eigenvectors. So this is, we don't have time in a micro-tutoring session to actually prove this. So this is a result for calculating the square root of a real symmetric matrix. So we just use this result to obtain the square root M matrix, the square root of the A matrix. So if we just go ahead and calculate this out, this is our answer that we're looking for, and I'm not going to go ahead and calculate that out in the interest of time. So this is the result that we're looking for. The square root of the A matrix is the eigenvector matrix times the square root of the diagonal matrix of eigenvalues times the inverse of the eigenvector matrix. So that is written out here. So that's it for today's micro-tutoring session from Prep Plus. Prep Plus is your online solution for customized learning in math and physics for high school, college, and returning scholars. I'm Rodney Green, the president of Prep Plus, and I invite you to contact me to schedule a free consultation. Check out the website prepplusinc.com.